So here we go with the start of chapter 2. Chapter 2 is a section on functions and graphs, and we're going to start by looking at the modulus function. And the modulus function is a function which takes a value, and whether it's a positive or negative number, and gives you the size of it. So in effect, the positive value. The magnitude or the modulus. We could think of this as the magnitude. Yeah, the magnitude. Or another phrase they use is the absolute value. So a modulus function is in general a function of the type y equals f of x. So x is our input value. So this is the input, x is the input, and the y is the output value. So what you get out from the function. So when f of x is greater than or equal to 0, so when the output of the function is positive, then the modulus of f of x is also equal to f of x. When f of x is less than 0, so the output is negative, the modulus of f of x is equal to the negative of f of x. In other words, you make the value positive. So, we've got some examples down here. Example 1, part A. The magnitude or the modulus of negative 2x, so you put in a negative value, but we want the magnitude or the size of it, so that's equal to 2. B, if the input is 6.5, then the output, we want the positive of that, is also 6.5. Part C, we want the modulus of a third take away 4/5. So the modulus sign here is a bit like brackets. We have to do the bit in the bracket. Yeah, we need to do this bit first before we apply the modulus sign. So first calculate inside the modulus signs. So we get a third minus 4/5, so we want our denominators, lowest common denominator will be 15. So the 3 has been multiplied by 5, so we get 5. So a third is similar to 5/15 minus 4 over 5. Well, we want a common denominator, so that's been 15. So that's been multiplied by 3. So negative 4 times 3 is negative 12. 5/15 minus 12/15 gives negative 7/15. And now we take the magnitude or the modulus. Magnitude, the positive value of this, if you like, the size is 7/15. I hope that's clear. Now I think example 2 appears below. Yes. So f of x equals the magnitude of 2x minus 3 plus 1. Okay, so again, x is our input. Yeah, these are our input values. And f of x is our output. So write down the value of f of 5. So f of 5 is equal to, And it's a bit like state subsolve, yeah? So this expression is like our state. So now we're substituting in. So we get the magnitude of 2 lots of, and when we substitute in, we put it in a bracket, take away 3 plus 1. So now we've got 10 take away 3 inside the modulus plus 1 outside. So we get 7 plus 1, or the modulus of 7 plus 1. Well, the modulus of 7 is already positive, so the modulus sign is making no difference. So we get 7 plus 1 equals 8. So we've got that state sub solve structure. Part B. We're going to put in -2. So f of -2 equals 2. Substitute in a bracket, -2. That's our x value going in. Take away 3 plus 1. Work out the bit in the bracket. Yeah, so up here, we did that bit first. Here, we're going to do that bit first. The bit inside the bracket first. Do first. Do first. The bit inside the modulus sign. So we get -4 take away 3 plus 1. So that becomes -7 plus 1. Apply the modulus. So we get 7 plus 1 equals 8. Okay, interesting there that you put 5 in and you get 8 out. And also you put -2 in and you get 8 out. Okay, last one, f of 1. Part C, so f of 1. 1 is our input, so we get 2 lots of 1. Take away 3 plus 1. Again, we do the bit first inside the modulus sign. Do first. So we get 2 take away 3 plus 1. 2 take away 3 is -1 plus 1. But the magnitude, the size, the modulus, all the same meaning. The absolute value of -1 is 1 plus 1. So we get 2.